So one thing we didn't talk about much yesterday that I want to make sure you guys remember, and this is something that you should remember how to do from last year. Anybody remember how to factor a sum or difference of two cubes? You should know how, everybody knows how to factor a difference of two squares, like x squared minus 9. That factors into x plus 3, x minus 3, right? But does anyone remember how to factor a sum or difference of two cubes? It's not 3 times, there's only 2, but there's a binomial and then a trinomial. So what's the cube root of x cubed? X. What's the cube root of 8? Negative 8. Negative. Am I good so far? And then, it's real simple. You square the first, which would be x squared, opposite the product. So if you multiply these together and then take the opposite of that, which would be plus 2x. And then the second one squared. Somewhat remember how to do that? No. So try, how about y cubed plus, we'll do 125. So what's the cube root of y cubed? Y. What's the cube root of 125? 5. Positive 5. Yes? First one squared, y squared, opposite the product, minus 5y, the second one squared.
I remember this, we had like a whole thing written on the book. Yeah, he did it 10 times. He would always leave like all the formulas up on board for us.
Well, you can do this by the formulas. The formulas are actually on page 136. You can do this by the formula. But I always find it easier if I have to factor something like sine cubed plus cosine, well, we'll just do 1. This is a sum of two cubes. So, what is the cube root of the first one? Sine. What's the cube root of 1? 1. And then you take the first one squared, which would be sine squared, opposite the product, so minus sine, second one squared. I think that's the easiest way to do that. You just got to remember cube root, you do the first one squared, opposite the product, so you just multiply them together and you do the opposite of that, second one squared. And if you remember that, it works for sum. It also works for the difference of two cubes. So if I have to do, let's do a yucky one, like tangent cubed minus sine cubed. Well, what's the cube root of tangent cubed? Tangent. What's the cube root of negative sine cubed? Minus sine. And then, first one squared, tangent squared, opposite the product, which would be plus sine tangent, doesn't matter order, right? Second one squared, plus sine squared. I think that's the easiest way to remember how to do those.
Yeah.
Huh? So all I did was cube root, yes? This is nothing more than the first one squared. This is opposite the product. So you multiply those two together, take the opposite of it. This is just the second one squared. That's all it is. Right, Olivia?
Yeah.
Okay. The question is, when am I going to need that? Well, you may run into a problem that looks like this. And yeah, this is actually going to be from your homework. This is number 9. Tangent cubed minus 27 divided by tangent squared minus 9. That is supposed to equal tangent squared plus 3 tangent plus 9 divided by tangent plus 3. And our job is to get those two things to equal. Well, sometimes when you do these, it really is just a simplification problem. There's nothing else to do other than simplify. Now this one looks like the left side is more simplified than the right side, but because of the squareds and the cubes, that's actually not simplified. So if we factor those, what does this numerator factor into? That's a difference of 2 cubes. So it'd be tangent minus 3, right? Tangent minus 3. What's the first one squared? Tangent squared. Opposite the product, which would be plus 3 tangent. Second one squared would be plus 9. Now that is a really, really good thing. What's significant? Good thing for us. This is the same as that, right? Great. All I got to do is get rid of this, and I'm done. Factor the bottom. What's the bottom factor into? Tan plus 3, tan minus 3. The tan minus 3's cancel, and yes, I'd be done. All I have to do is rewrite it. Tangent squared plus 3 tangent plus 9. My pen is not working right. And I'm done. Okay? So sometimes when we do these proofs, all you really have to do is simplify. Sometimes the way these proofs work is you just have an unsimplified expression on one side, and on the other side it is the same thing, it's just the simplified version. All we have to do is simplify it, and we're done. Okay? Are we good with this? Is there any substitutions that I had to make with some of these? No. I could tell you right off the bat with this problem, there wasn't going to be a single substitution I was going to have to make. Why? It's all just tangent to begin with. If it's all just tangent to begin with, I'm not going to have to make any substitutions. Now, let's say I give you something that looks like this. Let's talk about some strategies. 19. 1 plus cosine over sine plus sine. This is number 19. 1 plus cosine. Now, let's say, for example, that that's my left side. Now, my other side is 2 over sine plus sine squared plus cosine squared. No, I don't want to do that. Sine over sine minus sine. Let's say I gave you this.
Where are you getting that?
Shh. I'm talking about a strategy here. Now remember, we're not actually doing real trig proofs just yet. We're building up to it. What I'm trying to do is I want to show you a technique. The question is, when would I use this technique? When you see a problem that looks like this. On the left side, I see a 1 plus cosine over sine. Over here, I got sine over 1 plus cosine. I don't know what the right side is. I just made this up. But what do you see on the right side? It's all sine. When you see something like that, because guys, I will tell you right now, Most of the time, what step do you think is the hardest step? Where to start. You're going to get, there's going to be so many proofs that you look at it and go, I don't know where to start. That's very, very common. So what I'm trying to do right now is I want to try to give you one or two things of, when in doubt, hey, here's a starting point. Here's a first goal. If I saw something like this, I would approach this with my first goal. What do you think I want to do with my left side here? Turn it all into sine. I'm not going to try to get them to match yet. My first goal is not to get them to match. My first goal would be, can I turn this into nothing but sine? Once I get it there, then I'll worry about getting them to match up. Sometimes my goal is just simply, can I take this and turn it into nothing but sine? Does that make sense? So it's not a real proof. I can tell you right now, this is not going to work. Why? I just made this up. I just threw some signs up here to demonstrate this is what it might look like. So then if it looks like something like this, and I go, man, I don't even know where to begin here. Well, here's a starting point. Take this, and let's see if we can figure out a way to make some substitutions, just get it to sine. That's my first goal. And if I can accomplish that, then I worry about matching them up after I do that. Does that make sense? Okay. So, let's get rid of this because I don't even know what this is going to equal. My goal here is simple. Can I turn this, get rid of all the cosines? I want nothing but sine. Now, there is a lot of things in my 1 plus cosine was equal to? No. So what else could we do here? Hey, that's a good idea. Let's get a common denominator and add those together. If I have a sine and I have a 1 plus cosine, what would my common denominator be? Well, I would need a sine. I would also need a 1 plus cosine. That's what my common denominator would be. Yes? Great. In this denominator, what was missing? 1 plus cosine. Well, I already have a 1 plus cosine. Now I have 2 of those. Yes? What's missing out of this denominator? Sine. Well, I've already got a sine. Now I have 2 of those. Now, could I distribute in the bottom? Yes? Could I distribute here in the bottom? I could. And sometimes you're going to have to, sometimes you're not going to want to. Everybody look at that toolbox page I gave you yesterday. If I distribute this, I'm going to have a sine. I'm also going to have a sine times a cosine, aren't I? Is there anything at all in that toolbox that deals with sine times cosine? Where? What's sine times cosine? Is there anything at all? Nothing. For that reason and that reason only, I like to avoid those. Because, now, I could distribute later. Maybe I don't do it now, but I'm going to save that for later because I know, odds are, I'm going to want them separated anyway. Because there's nothing I can deal with sine times cosine. So in the bottom, I'm going to leave that alone. Now, the top, what do you think I should do with this 1 plus cosine squared? Foil it out. If I foil this out, it'd be 1 plus 2 cosine plus cosine squared. And then I still have the sine squared. Now, there has to be a handful of things when you do these that when you see it, boom, red flag. Hey, look at me, use me, do something with me. In this, what do you think is that red flag of, ooh, look at me? Cosine squared plus sine squared, right there. This is 1. So, when I make that substitution, boom, this becomes 1. Now, technically speaking, I would like to see you guys on the next step. Again, I have to be able to follow your logic. The easiest thing to show is 1 plus 2 cosine plus 1. This became 1. Now, if you jumped right from here and skipped this step, I'm pretty good at these. I probably could have figured out what you did there. But you got to get to here. Everybody see how I got to there? All I did was 1 plus 1. This sine squared plus cosine squared. This became 1. Because that was a substitution. That's something you have to see. Now, we're kind of stuck here. Can I factor that top? What can I do? I can pull it. Oops. I can pull a 2 out. Right? And if I pull a 2 out, what do I have left? 1 plus cosine. Hey! What can I do? Cancel out. And I'm all the way down to 2 over sine. Now, did I know what the right side was? No, I didn't know. Now, maybe the right side was more complicated than 2 over sine. I've accomplished my goal. I've got it just in terms of sine. It just happened to also be a very simplified thing. Maybe this side is also more complicated, where I have to do a little simplification. But if this was all in terms of sine, now I've got a fighting shot of getting them to match up because they're the same trig function. This is just one technique that I want you to practice. Are you going to use this technique for all of these proofs? No. Every proof is different. Some proofs, some puzzles, some jigsaw puzzles, you group things by colors, right? You say all the flowers over here, and you put there's a house in there, so put them over here, right? And you try to work those together. Can you do that? Can you use that technique on every puzzle?
No.
Why? Maybe the colors are just so similar all the way through. There is no distinction between this color versus this color because they're all pretty much the same color. So you're going to have a different technique to put them together. Okay? So, when you guys do questions like number 17, there's no goal here of get it to equal something specific. There's no right side, left side. But the way I want you to approach this, so it says tangent times secant. The way I want you to approach this, we don't know what the right side is. But I want you to pretend it's something like sine squared plus 1 over sine minus 2 sine squared plus 1 over sine. Something crazy like that. But what does this side have? What's significant about this side? It's all just sine. So what is our first goal? To get the other side into nothing but sine. Once I accomplish that goal, then I would worry about trying to match them. So, what's a substitution I can make? Great, tangent sine over cosine. Now, it doesn't get me entirely into sine, but at least it gets me in a good direction. It's better than going into 1 over cotangent, right? Okay, what can I change that secant into? 1 over cosine. Well, let's multiply across. What do you get? Sine over cosine squared. Is there any substitutions I can make? Do I have anything in my toolbox that equals cosine squared that turns it into sine? So sine, that cosine squared can become 1 minus sine squared. For these problems, is there anything that even says your bottom line and my bottom line have to match? No. What's the only goal here? Get it all into the same trig function. If you have the same trig function, you're done. Because we're not trying to get it to match anything yet. We're practicing a technique that's useful when we do some trig proofs. Keep in mind, are we doing real proofs yet? No. We'll start those tomorrow. So, on the homework, the first few problems, when you do 1 through, honestly 1 through 16, they're pretty much just simplification problems. There might be a couple substitutions down the stretch. Yeah, the first one is just a substitution. Well, you got to FOIL and then make a substitution, but yeah. Okay. But then when you get to number 17, the goal is different. You're not trying to get it to match anything. You're just saying, let's put it in terms of sine. For number 21, what's the goal? Turn it into cosine. Don't care what it looks like. Just get it to cosine first. Then we'll worry about matching it. And then the last one, then you get 25, turn them into tangents. Find a way to turn it into tangent. Then the last few, you know what? You guys can stop at 30, by the way. You don't have to do a 31, 32. Stop at 30. I know, I'm a nice guy. Yes. Okay, no. This is the book's way of having fun. Sometimes it likes to use the theta. Sometimes it likes to use the alpha. Sometimes it likes to use beta. Sometimes it uses... Is there anything else in there? That's about it. It's just the book having fun with the Greek alphabet. We're not writing them anyway. It means the same thing. It's just a different symbol. Instead of theta, using a different letter. It doesn't mean a single thing to you. I'm not even going to make you write them, so just ignore them. Okay? So, number 1. Great. 1 minus sine. 1 plus sine. That is supposed to equal cosine squared. Yep. FOIL. If you FOIL these together, what do you get? 1 minus sine squared. Because the middle terms just cancel, don't they? Isn't that just a factored version of like a difference of 2 squares? Great. Is there a substitution I can make? What's equal to 1 minus sine squared? Cosine squared. And you're done.
Wait, what?
So all I did was FOIL.
No, yeah, I just don't.
And then this is a substitution. That's in your toolbox. Guys, you have to have your toolbox memorized. You really do. And the reason you have to have your toolbox memorized, the reason I am being mean about make sure you memorize your toolbox, it is not because I want to be mean and just make this class harder. It's really not the reason. The reason, the benefit of you memorizing your toolbox is more of an identification thing. The hardest part of these is making substitutions when you should make the substitution. How do I know to make a substitution here? Because I recognize it when I see it. If you don't recognize it when you see it, you're going to go right past it and you're going to do something else. If you don't have your toolbox memorized, you're not going to see and recognize the substitution that you should make when it shows its face, because you don't know them. But if you know them really well, there'll be some triggers for you. You'll see it and go, ooh, 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 I should do something with that. Okay? Yes? 4? Sure. So number 4 says 1 plus tangent times 1 minus cotangent. And that's supposed to equal tangent minus cotangent. Well, I would FOIL. What do you get when you FOIL? 1 times 1 is 1 minus cotangent plus tangent minus tangent times cotangent, right?
Yeah.
Now, is there something, now most of this is good, or some of it is, because I have a negative cotangent. Well, I have what I want, right? I need a positive tangent. I've got that. I just don't want this one, and I don't want this thing. Now, is there something in my toolbox, tangent times cotangent? Isn't that 1? Because aren't they reciprocals of each other? So this just becomes negative 1. So what happens to my 1s? They gone, and all I have is negative cotangent plus tangent, which is the exact same thing as that. Just backwards. So keep on chugging. Try to get through 30 tonight. Tomorrow I'm going to give you a big list of tips of what kinds of things you can do. What are some good techniques to try, some tips. And then we'll start working on the real ones. All right?